In this final example, we'll be looking at somebody that gets money regularly. Not continuously, but regularly. Let's say that Corey has some apartments and he gets $4,000 per month in rent for tenants. He invested all at a continuously compounded interest rate of 5%. This is not a money flow because he's getting money at a specific time, not continuously. But what we want to do is we want to use a money flow to approximate this investment. So first question. So we need to come up with an f of t. We're not given a rate. So we know it's $4,000 a month. But our money rate is in dollars per year, so let's say $12 per year. 12 months per year. And so that would be f of t. F of t would be $48,000 per year. So this is a bit like the first example we did in the sequence when we talked about what f of t should be for constant flow of money. Well, this is it. We're assuming that the money, instead of coming in one lump sum at the beginning of each month, comes in continuously at a constant rate throughout the month. All right, so if we assume this, what's the present value of this investment? If it goes on, oh, I didn't give you an interest rate. Oh yeah, interest rate of 5%. So what if it goes on for 5 years? So it goes on for ... 5 years. So I'm asking for present value, so that's in today's dollars. I haven't computed the future value, so the fastest way to get the present value here is to actually use the formula with an integral. So present value is the integral from 0 to 20. Well, let me write the formula. 0 to t, f of t, e to the minus rt. Again, I like to think as minus t years, so it's in fact, if you receive it at year t, but you want its value at year 0, so you want to go back in time t years. That's why there's a minus t. So in this case, we said 5 years, f of t was $48,000 per year. The interest rate was 0.45. Let me double check. 5%, so 0.5 t. I'm going to integrate this. So I'm getting 48,000 e to the minus 0.25 minus 1 over minus 0.05, and that should give you, I have it here, let me double check that I have the same thing. It gives $212,351.25. All right, so if this goes on for 5 years, in today's dollars, it's worth $212,351. All right, but why would it stop in 5 years? Unless he has like temporary ownership, he's actually renting it and subletting it. This should probably go on until he sells it. So what if it goes on forever? Then I'll write the same integral. But now this t is plus infinity. It never will stop. So that would mean he would pick up $4,000 of rent for the rest of time. This is an improper integral, so I have to write it as a limit. Let's put big T goes to positive infinity because that's quite nice, and I have little t here, I don't want to get confused. 48,000 e to the minus 0.05 t dt. All right, now I'm going to do the same thing I did here, so I'm going to plug in t and plug in 0. I'll just have one final step to take, and that's to send t to infinity. So here, limit as t goes to positive infinity, 48,000 e to the minus 0.05 t minus 0.05 minus 48,000 times 1 minus 0.05. All right, now this is a constant, so that part is easy. As t goes to infinity, that first bit would come, this is infinity, so I'll get minus infinity. Now, remember your cheating brackets, but here e goes to 0 when you go this way. If you go to minus infinity, there's an asymptote, a horizontal asymptote there. So that first bit is going to 0. So this is going to be your answer. And that should give you $96,000. So this investment, if it goes on forever, is worth a bit under $1 million in today's money. So in this problem, we're approximating the answers because we're using a constant money flow instead of the real situation, which gives us money at the beginning of each month. If you actually wanted to compute the real value, the exact value, you need to use series and you need to use annuities.